Okay, we're taking our next step in this little project, and by now you have already got a little picture going of some kind of a, well, I don't know, maybe you did a car. I gave that example before. Here's a square root to start it off, and then maybe, or maybe like a spaceship. Here's another square root going the other way, and then I could have a square root going up here and a square root going here. And then I could do the bottom of the spaceship as a big parabola, or I could have just done the top part as a big parabola. Anyway, that's the beginning of my little spaceship. You've got a project and you're trying to like start figuring out where lines touch. Do you get that if you want the top of this spaceship to touch this line perfectly, that it can be kind of complicated to get them to touch just right? Okay, so here's how you would do something like that with Wolfram Alpha. So going back to Wolfram Alpha, let's say that I had a simple absolute value equation. Okay, let's say that my simple absolute value equation was y equals absolute value of x. ABS, notice that stands for absolute value, x. Now let's just hit enter on that, and it says, okay, so you want to know about absolute value of x? Here's what it looks like. And Wolfram Alpha goes through and says, here's a whole bunch of graphs of it. This is a graph with a scale that goes up to 2. Here's a graph where it goes up to 12. Here is the alternate form, assuming x is positive. As in, if x was positive, your absolute value would be the exact same thing as x. Here's another way to write that. Here's another way. I didn't need to know how many calories are in a pound of butter. Anyway, this is the root for that equation. The domain is all reals. Look at this thing. Like it answers everything possible out about absolute value, because it doesn't know what you want to know. What if what I want to know is how could I get a parabola to like intersect with this thing, like right in this neighborhood? Would you guys agree that I would need a parabola that is shifted to the right and maybe up? Okay, so then let's type another one and we'll say equals. So everybody hit equals. And then we're going to type in a parabola. So that's x to the power of 2. And except I want to move it to the right. So how do I do that? X needs to be in parentheses. And to the right, let's say right 1. How do I do that? Minus 1. Oh, there's 2. Sorry, let's go x minus 1. There, I moved it to the right one. Now, if I set them equal like that, it's going to graph both equations. Do you get what I'm saying? It's going to graph the absolute value, and it's going to graph the parabola. What's cool about it is that not only that both of them graph, see how they both graphed? I can see where they cross. And so, like, if I only wanted this to be shooting out the side here, okay, or my parabola to only be going up from there, I can tell that right there where they intersect, it'll tell me where they intersect. It's called the solutions. This is the exact spot where those two intersect, which is really pretty complicated. All right, so if you want to know where two lines intersect, you set them equal to each other on Wolfram Alpha, and then you can know, oh, I want to for sure have a window. Do you get that if I limited my domain to be starting at about 2.6 and on, that then I'd have a parabola? And my absolute value, if I said I only want to see my absolute value between 2.6 and 4, then it would only show this blue line right here, and it wouldn't show any of that. And how do I know? I can tell where they intersect by looking at my graph that I got off of Wolfram Alpha. So if you want to see where two lines intersect, set one equation equal to the other equation, and then you'll be able to tell wherever the dot is, that's where they intersect, and that'll help you in your project to see where you can get things to touch. Okay? So I now have a worksheet I'm going to hand out to you and show you where this is going to be handy on this homework I'm giving you. and in the project. All right, so I just handed out a sheet. Actually, hold on. Okay, so now that you have the worksheet in front of you, it's the top part is the rubric. How many points are the graphs worth? 4. How do you get those 4 points? You have to include 2 of each, a circle, 2 semicircles, 2 absolute values, 2 square roots, and 2 parabolas, x squared. Excuse me. All right, equations. The equations are how you're going to get the graphs. And you type in your equation, and if your equation is right, your graph will be right. So obviously those are going to pretty much go together, those scores. Now, could you possibly get a 4 on graphs and a 3 on equations? Yeah, if you had the equation where you had not done it properly, but you'd gotten the picture to work. Anyway, long story, but as long as you do a good job on having all 10 shapes in there, you got 8 out of the 16 points. 2 points for creativity, and we're going to generally say that it'd be almost impossible to get a 0 on creativity. Okay, so you're either going to get the 2 or the 1 on creativity. The quality. Picture is neat, and special attention has been paid to all intersection points on the picture. Like if I make a picture like this, what makes it look really sloppy is that the lines aren't lining up and touching. You know what I mean? And this one I could tell would not have a high quality grade because things aren't touching really nicely. So you got to be really careful in how you arrange these. Oops, marker's missing. Hold on. So I got to undo that. And this, like right here, I really needed to move that over like about there, and it's still not matching up perfectly, but anyway, I'm trying to get my lines to match up better. You ought to do the same thing. So that's already cleaned up a lot. That'd be a better quality score. Okay, moving on. Look at the lower left side. It says, show each step in solving a parent circle equation to put it into y equals form. I've showed you in the past, like that, how to solve a simple one. That is a simple one. What you have to do is take an equation from your picture. All of you are going to have a circle, right? It says you have to have a circle. So you're going to start with x squared plus y squared equals like 16 or whatever it is, wherever your circle is. And you just have to solve it for y. Yes, it's more complicated than the one I showed you because you got a little more little parts in yours, but it always involves absolute value. Remember when we take the square root on both sides, you have to have absolute value. And then it always breaks into 2 equations then. Absolute values break into 2 equations, where one's positive and one comes out negative. Okay, so anyway, that's how you're going to do the one on the left. You got to use an actual circle from your graph. Then everybody look on the right, please. On the right side of the bottom of the worksheet. It says, describe in detail how you were able to get the intersection point for 2 of your parent functions. So, and a good example would be, I took the square root function, and I took the parabola, and I put them into Wolfram Alpha to see where I could get the 2 lines to touch. Now that would be a little too generic to get all 2 points. You'd have to actually show me, here's my this equation, here's my that equation. I put it into the Wolfram Alpha, and it told me that they touched at x equals -3 or whatever. Okay, so be specific about how you get them to touch. All right, so that's an example of using Wolfram Alpha to see where your equations are touching, and that also oftentimes tells you where you want your domain to be. Like if I only wanted to see this blue line, from there on, I want to set my domain at x is 2.6 to x is, let's say, 4. And then I'd only see the blue line in this little zone. Okay, so Wolfram Alpha helps a lot to see exactly where those 2 lines are crossing. Any questions about the new stuff I've just told you? Okay, so moral of the story is, don't try to be too complex right now, or you make this incredibly beautiful thing that you can never actually put into the computer. So try getting it in partway today, get a few shapes going. You'll see how it's more complicated than you think to type all these things in. And you don't want to try to have 35 equations that are super complex. It'll be impossible to finish. Okay, so this would be an example of a good one. I'm holding it up for those at home. I can't show you, unfortunately. But it appears to have 2 circles. It'd be fairly easy to have some of those be half circles because you could solve them for y, and then you could have the top half of the circle and the bottom half of the circle. So your half circles can be put together to make a circle. All right. So then it's got pointy ears. I'm guessing those are absolute values. Okay. And then the tricky part for that is trying to cut them off in the right spot. So you use a Wolfram Alpha to see exactly where those spots are that they're supposed to be touching. Okay. And once you did that on Wolfram Alpha, you got like top of your bird's head, and you got this absolute value that's going here and there. You'd be able to look it up on Wolfram Alpha and see, oh, I guess I should have my domain be from here to there, and you'll be able to see on Wolfram Alpha exactly what to limit your domain to, so that that absolute value, which should theoretically go forever like this, you don't want it to actually go forever, right? You want to cut it off so that it touches just right. Yes, sir. Yes, you can stretch things, either circles or half circles, very easily. Do you know how to do it? Awesome. So can you just tell, for those that don't know how to do it, if I had just a simple circle to start with, how could I get this to be more of an egg shape? Like stretched in one direction. So like, let's say I want it to be more like this than a normal circle.
So then you would put a stretch bar in place and like a 2.
Very good. On which one? Yes. If I put a 2 right here, I think you'd find that that's going to stretch your parabola, or stretch your circle in the Y way. And then it may not look exactly like this, but it would be more stretched. So you can play with that and see how it looks. There's a lot of that. I type it in this and I go, oh, wait a minute, that didn't do what I want. And I go back and change the number to something else. You need to get stuff in your iPad today and get at least, I would say by the end of the hour, you should have at minimum 3 equations, maybe 4, that are on your picture that are actually starting to build your picture. If you just spend too much time on the paper part, it will really make it hard for you to finish this on time by Friday. Okay? All right, that's all I have for you for today, and it's a work day, and I encourage you to come up and ask me questions about how to, how can I write this equation, or this won't work, or whatever, and I'll help individuals.